So I'll start with the Air UVC system here. This is the Air 2000, named after the Norse god of healing, air, and it's a system that's designed to process the air within an environment, to remove particulate, virions, whatever needs to be removed from the air. It uses a unique combination of both UVC inside here and also HEPA, which is high efficiency particle arresting filter, H14 grade, at the top here. It's also extraordinarily quiet. Believe it or not, right now, even though I'm mic'd up and stood right next to it, it's running at 1,000 cubic meters an hour of clean air delivery rate. And yet, you will not be able to hear it on the microphone. This system is heavy-duty construction. It's designed to last. It's designed to be your partner for a very, very significant period. How it works is the air comes in through the bottom here, either side of the system, and is inducted into the UVC reactor. Now, we call it a reactor because it's completely self-contained. Human beings should not be exposed to high levels of UVC, and therefore this means by containing the UVC that we're able to be in the same room with the device on a really long-term or continuous basis. Once the air has passed through the UVC reactor chamber, it then moves up into the air fan chamber. And this is the area where the fan is then moving the air through the baffle plates and through the HEPA filters at the top. When the air exits the HEPA filter here, we use a trapezoidal exit. The trapezoidal exit is used for several reasons. One, it means that there's no danger of obstruction of the top of the unit. But two, it acts as a baffle plate from an acoustic perspective, because air is slowed down by hitting the top plate here and then is exhausted around all four sides of this trapezoid. And it means the system's even quieter. Furthermore, the system is completely portable and plug and play. It requires no external ducting, no external specialist power feeds. It runs on single phase 220 volts, and you're able to plug it in wherever it needs to be and use it. It's completely touchscreen controlled and it's IoT connected, so it is smart. It feeds data into the FincenTech cloud, and we monitor the key metrics such as the pressure differential or delta across the filter here at the top. So we actually tell you that your filter's becoming blocked before you even know there's a problem. In most cases, you have one delivered to you and you, oh, that's a surprise, I must need to change my filter. The system will also illustrate to you and give you warnings on this touchscreen control panel to tell you when the filter's becoming blocked. Now, why is that important? Most manufacturers will tell you you need the filters to be changed at regular intervals. Some manufacturers say it's every day, some manufacturers say every week, some manufacturers say every month. Now, the truth of the matter is every environment, every application is entirely different, different levels of contamination. If you're using this system in a sawmill, it's going to get clogged a lot quicker than it would in a hospital. Having the pressure delta monitor enables us to adapt to this and ensure that you're not wasting valuable resources in changing unnecessary filter changes. The touchscreen also has an integrated scheduler on it, and you can adjust the airflow of the device. Now, I want to touch upon airflow, and I want to be really, really clear. This system is called the Air 2000. When we were designing these devices, the key metric for us was the clean air delivery rate in a volumetric form. If you're talking about cleaning the air in a room, you have to think three-dimensionally. You have to think from a volume perspective. And this system will do 2,000 cubic meters every single hour of air. And the reason we need to do cubic is obviously because you have your meters square, the size of the room, but the height of the ceiling can double or triple that. So doing just simply square meter calculations for a system when you're calculating the air delivery rate or how much air you need to be processed is ultimately meaningless. 2,000 cubic meters an hour it will deliver, but this system you can also turn it down as well. You can adjust it to 1,500 meters, you can adjust it down to 1,000 cubic meters an hour, depending what you want. All done through the touchscreen, and you can schedule the fan to ramp up or ramp down different times of day or night depending on the traffic in the area. And that's another beautiful thing about this particular system here. Because it's plug and play, because it's portable, any time that you have an increase in traffic or you have a room that's bigger and bigger and bigger, you just simply deploy multiples. It's that simple. You just simply deploy multiples of the unit to give you the calculation that, trust me, in years to come is going to become more and more important, which is your air changes per hour. And air changes per hour, you'll need to know the cubic meter capacity of your device to calculate that out, as well as the volume of your room. In terms of filter changes, we took a rather unique step with this device. We want our customers to feel comfortable with the system. We wanted to reduce the reliance on engineering and service and support. There's no requirement realistically for an engineer to come and change your filter, unless you want them to. So, whereas most devices have panels that you need an engineer to unbolt, unscrew, lift out, and take everything out, and it requires tools, this unit has a completely toolless filter change. We simply put a lockable door on the back that you or the owner or the customer or whomever will have control of. You simply open the door and you change the filter. It takes 15 seconds to change the filter from opening the door, changing the filter, and closing the door. So it's really, really effective, really, really fast. And it means if you have spare filters on site, that you can respond to any requirements really, really quickly. The door on the back also allows our engineers to access the fans, to access the intake filters, to access everything else that we need to access in a moment. The system is heavy-duty construction and designed to last a minimum of 10 years. This is not a plastic device. It is a system that is designed to last for a very long time. We want to be your partner, and we want this system to be your partner for a very extended period. So it is a galvanized steel construction with a heavy-duty chassis, and it is designed to last an extraordinarily long time. And that, in all honesty, is the air systems. They are relatively straightforward, but making them high power is really, really important. But there is one feature that no one's talking about with air systems at the moment, and this is my final message, and that is the noise they make. Now, my background was in turbine engineering and in power generation and other aspects where acoustic engineering is absolutely key and critical to ensuring that you deliver the right amount of environmental noise load. We spent a lot of time with this system developing acoustic baffling around the fans, around the intake, and around the exhaust to ensure that this system is the quietest in class. And as I said before, I am stood right next to it with a microphone just here, and it's running at 1,000 cubic meters every single hour. And you can't hear it. And that means it can be used and deployed in schools where people need to concentrate. It needs to be used and deployed in care homes where they need to run 24 hours a day, 7 days a week, and when people need to sleep. It can be used in recording studios where you don't want the levels of background noise, but it's still keeping people safe. These systems keep people safe when they're on. That's the power of these systems.